So I'm continuing my video series covering the design of this house, and in today's video we are covering the late stage design process. That is the design development process and the construction drawings process. What does it look like in late stage at an architecture office? What are some of the things that you should expect as a homeowner when it comes to the drawings, when it comes to the design process that is late stage? What does it look like when it comes to engineering and when it comes to the contracts associated with engineers and architects? All that stuff's going to be in today's video. If you're new here, my name is Jacob Wimsatt with c.w.architects in Nashville, and my company specializes in creating custom modern residential architecture all over the Tennessee region. So with that said, let's jump into the late design process. Okay, so let's cover a little bit of a recap. So in the last video, we discussed the schematic design process and some of the early stage of design when it comes to pre-design, gathering that information when it comes to zoning and all that stuff, and putting it together into a series of explorations that start to try to solve the design problem. The video also covered things like doing a concept, what the importance of a concept was. So if you missed any of that, go and check that out. But this is, of course, added on to that. So in general, in the architectural design process, like I've said before, we start very broad and then we work into specific. So we're always layering on detail as we go. We don't want to size beams when we don't even know the layout of the house yet. We don't want to understand, or we don't want to try to solve the layout of the house if we don't understand the program and what characteristics that you're wanting in the house. So this is the next stage of layering that information on. So we've done our prototype. We know what the building's going to look like, how it's going to lay out. And we've got this idealized version of the architecture. And what we need to do now is make it buildable. So that is the big goal of the design development process, is we are converting that prototype, we're converting that idealized version, that goal, into something that's actually buildable. Now, what is this going to do to that idealized version? Well, it's going to change it. It's going to modify it. But hopefully, it's going to modify it on a more detailed level. It's not going to be moving, the living room to the other side of the house. It's not going to be it's not going to be changing the layout. What it's probably going to do is start to change the thicknesses of the floors. It's probably going to start to determine the height of the basement walls. It's going to make changes to that idealized version, but my job is ultimately to try to keep that as consistent with that prototype as possible. Now, once we get through the design development phase, once we've done our engineering, it's going to be time to get into construction documents. And all that really is creating a series of drawings and specifications that you can then communicate all that information to the contractor with. So contractor and suppliers and all the folks that are going to be contributing to the construction of the project. So the first stage of late design is going to be design development. The second stage of late design is going to be construction documents. Okay, so before we dive into the real specifics on the design development or the construction documents phase, I just wanted to go over a little bit of the contractual relationships and what things you should be expecting from your architect when you're doing a build. And the first thing is that think of the architect as the general contractor on the design side. So what I mean by that is, like the general contractor hires a plumber to do the plumbing, and like the general contractor hires an electrician to do the electrical work, the architect is going to hire an electrical engineer to do the electrical design. They're going to hire the mechanical engineer to do the plumbing and mechanical design, the HVAC design. And then they're going to hire a structural engineer to do the structural engineering, figure out, the frames and the framing, the steel, all the stuff that holds it up. Those folks are subcontracted under us, and then it becomes a one-stop shop for the design for the owner. So why is it needed to have a structural engineer or an electrical engineer or any of these other folks that we have to hire for as a design professional? Well, the way I like to explain this to folks is think of your architect and your general contractor. They have the same level of generalized thinking. So both the architect and the general contractor know a little bit about everything, but they don't know everything about one thing. Just like the electrician doesn't know a whole lot about the mechanical or the framing or some of these other things, they are a specialist and they know everything there is to know about, or at least hopefully they know everything there is to know about the electrical side, the electrical work. Same thing with the plumber. The plumber doesn't know a whole lot about electrical, doesn't know a whole lot about framing. They focus in on plumbing. So the general contractor knows a little bit about plumbing and a little bit about electrical, and they really just know a little bit about those in order to organize and keep everything moving in the right direction, keep the process moving along. Same thing on the design side for the architect. Again, we're generalists, so we know a lot about a lot of things. We know a little bit about a lot of things, but we don't know everything about one thing. I have to rely on a structural engineer if it gets more complex. So the more complex the home gets, the more steel we use, the more glass we use. I have to rely on a specialist that knows the math behind all of that stuff in order to make it work, to make it buildable. Ultimately, my job is going to be to coordinate all those engineers, bring all that design together, and then in addition add the architectural design on top of it, which is like thermal, moisture protection, the look of it, the layout of it, the exterior finish materials. Basically everything but the structural, mechanical, and electrical has to come together under the architecture umbrella. So it does represent the majority of the design, but it isn't a specialized version of the structure. Okay, so what is the first step in design development? We've got the prototype, we're ready to move into engineering and figuring out how we're going to build this thing. What is the very, very first step? Well, the very first step is to make any changes or fix any issues that are associated with the prototype. So at the end of the schematic design process, we meet with our clients and we do a critique. We go over the things that do work and the things that don't work. And technically that prototype isn't complete until the very first step of the design development process. And that's where we go in and we take that feedback and we make repairs to it, and then we move straight into the engineering process. So the very first step is to make repairs to the critique from the client. Okay, so the next step in the design development process is doing a structural engineering evaluation. Now, on this particular house, the yard house, we needed to have a structural engineer. We knew that going into the design development phase because we've got a lot of glass. And like I've spoken before, if you've got a lot of glass, you're probably going to have steel because you don't have a whole lot of resistance against lateral forces. So let's go over real quickly kind of an initial meeting, what the first meeting with a structural engineer would look like on this particular house. So I'm going to pull up the model real quick. And again, you want to have this structural evaluation and you want to try to understand some of the challenges that you're going to face before you even get into the structural design. So having those early conversations, those early meetings with the engineer and working through some of the potential hurdles is going to be the first step of that structural evaluation. Now, looking at the house and looking at the house with the engineer, of course, this back glass wall is going to be the wall that they were most concerned about, and which is leading to a lot of the decisions being made about the steel frame. Some of the other concerns are the front glass wall. So really anywhere where there's going to be glass, there's going to be a concern from a structural point. But let's just zoom out for a second and talk about the overall. We don't have the whole house in glass, so we don't have to design a steel frame for the entire house. And that was part of the initial conversation, is perhaps we split this into two different types of construction. Maybe on the right side where there is glass, we're going to use steel frame, and then on the left side, we can probably just use standard construction, standard residential construction, studs, sheathing, that kind of thing. That's ultimately going to save the client money, and if you don't need it, you don't need to build it. So that was really kind of the result of that conversation is let's do two different types of construction, and it actually works pretty well with the architecture and the program. On the right side, where the glass and steel is the public space, the primary space where the living, dining, kitchen is. And then on the left, it's more support space, primary bedroom, stuff like that. So the structure and the program, the layout and all that stuff is actually starting to work together. So doing that structural evaluation is going to be important for not only the lateral resistance, but you're also going to start figuring out about how big some of the floor systems need to be. On any modern home, you're going to have issues when it comes to running ductwork. And the way we solve that in most cases is we use floor trusses to allow us to put horizontal chases in those floor trusses and provide a space for the ductwork to go. So right off the bat, we're starting to think through how big some of these elements are, some of these structural elements are. I'll cut a section through this just so you can see. On this particular house, we are using a 24-inch floor truss that's indicated in this kind of yellow solid element on both the floor and on the roof. Again, that allows us to get our ductwork in, but it also gives us the structural capabilities that we need in order to achieve some of the spans that we have. So having those conversations with the structural engineer early on, trying to understand what those assemblies are going to ultimately end up being, is part of those early conversations. That way we can start adjusting the height of the house, adjusting some of the plate lines, and figuring out how we're actually going to put the thing together. So let me walk you through some of the specific things that we were concerned about on this particular house in the design development phase. One of the main things that we were really concerned about with that glass wall is not only the lateral resistance, but how some of those components and pieces were going to come together. One of the things that the client really wanted was to have this seamless transition between the indoor space and the outdoor space, especially at this back porch. So just to orient you a little bit, I'm cutting through the back porch here and through the main living space. So the main wall that we're talking about is this particular wall here, and she wanted this seamless transition between this surface and this surface, and having that seamless transition is actually a detail that's pretty hard to pull off. So right off the bat, what we wanted to start to do is evaluate that particular element and start to figure out how we were actually going to achieve that. And to give you a sense, this is a building section that's cutting through that particular area, and you can see that this right here with this cloud around it is actually the spot that we're talking about. And what you see here is you've got the structure, which is indicated with this dashed line, and it's actually inset from the glass wall about a foot. So that steel column comes up, it holds up this steel beam, and then you've got this glass wall that's actually cantilevered out past it. So there's a header here that's supporting the window and on the top, and then below is, of course, the big sliding door that makes up that glass wall. And then there's this little metal element that sticks out and actually grabs onto that header. But all of that stuff needed to be detailed out, and it needed to be coordinated very heavily with the window manufacturer. So early on in the design development process, we're not only trying to figure out what the structure is going to be, but we're also starting to pick certain products. And in this case, we were picking a specific window and door manufacturer so we can have the exact specs of the threshold. That way we can start to design in this indoor-outdoor experience. So let me just zoom in real quickly into this one, into this detail. This is, of course, the building section. It's looking at the entire cut through the entire building. And then you'll see there's this little window here that I've highlighted in green. That's actually a wall section. And what that is it's going to zoom into that particular spot so we can start to dive into some of the details associated with it. So if I zoom into this particular wall section, you can see that it's basically the same thing from the building section, only it's zoomed in closer to start to figure out how we're going to do the foundation, how we're going to do the specific joint with the indoor-outdoor experience, and then, of course, how the roof's going to work, how the beams are going to work, how the header's going to work. So you can see this is the specific detail associated with the floor on the exterior and the floor on the interior. And the way that we are able to actually create that seamless transition inside and out is that we're actually setting the threshold of the door directly on a beam that spans between the steel posts. So it sets directly on the beam, and then the floor sheathing comes back, gets blocked in, and that allows us to get a little pocket in here for that door to actually sink down in just enough to where that floor finish can be seamless in and out. Now, the structural component of this is, of course, the beams, the columns, but the architectural component is going to be pretty much everything else. It's going to be the insulation, it's going to be the window position, the relative position of the steel elements and the window elements. It's going to be all the blocking and all the sheathing and all the stuff that needs to actually fill the gaps between all that, so all the stuff will actually fit together. The next spot I want to discuss in this particular design is actually the front wall. The front wall is going to be a little bit different from the back because of the overhang difference. So in the back we have this large overhang that makes up the rear porch, but then in the front you can see it's a smaller overhang, and what actually has to happen is all that stuff needs to cantilever out in order to create this profile. This little section could be even more difficult than the back section, because in the back section we actually have another column line out here that can actually catch the truss. So where we're creating this little pocket in this area where two trusses are coming together and putting the glass wall in it, underneath of it, on this particular section we actually have all that structure in the same line as the glass, or virtually the same line as the glass, and then all this other stuff has to be cantilevered out beyond it. Just know that the reality is that this particular spot, even though it's a glass wall and you've got the same structural offset, you don't have the same condition, and therefore a whole new set of details needs to be created in order to solve that particular problem. So the next thing I want to cover is the HVAC systems. So like we did a structural evaluation to understand what types of obstacles we're going to run in from a structural standpoint, once we get that structural tied down and we know what our assemblies are, we know how thick our floor systems are going to be, we know what we're going to make our walls out of. Once we have a general idea of that, then we can start digging into the next layer of detail, which is of course the HVAC and then eventually the electrical. So what you're looking at here is a plan of the basement level, and this is a full CD plan. This isn't at the DD level. The difference between the CD and the DD level are all the dimensions and all the tagging and all the communication elements that we're using to identify certain products. But in general, what you can see is that we've started to think about how the HVAC is going to work. And in this particular instance, we've got a series of mechanical rooms down in the basement that are going to supply the entire house. So in this particular design, we've got a slab for the basement floor. We've got a 24-inch floor truss that makes up the floor ceiling assembly between the basement level and the main level. And that floor ceiling assembly is where all the HVAC is going to go. But what you can see here is I've got several mechanical rooms that are aligning certain areas of the house, and the mechanical rooms over in this side of the house are going to supply and serve everything on this wing, and then the mechanical room over here is going to serve everything on this side of the house. So this is the example of the mechanical plan for this particular house, and what you're seeing here is that floor plan from the basement level, but we're overlaying all the ductwork and to show the contractor how we want everything to be laid out. And as you can see, just looking at it, there's a lot going on in these areas where I was talking about we dropped all these ceilings. So all that stuff is being crammed into this zone here, and then it's being crammed into this zone here and that zone there. So that should give you an idea of how things are starting to lay out. But anyway, this is a mechanical set of drawings that the engineers put together. Okay, so that just barely scratches the surface of the design development, and really all I wanted to do there is just to give you a brief sense on what later stage design looks like. And again, in design development, we're taking that prototype from schematics and we're converting it into something that actually works. And what that entails is figuring out the structure, figuring out how big things are going to be, figuring out how things are going to start to come together, what sorts of joints and sorts of issues and exceptions that we have to design for in order to actually achieve the final product. Now, the next stage of late design is actually the CD stage. And again, that's where we're simply communicating all those design decisions into a set of drawings. And in this particular project, we had electrical, mechanical, structural, architectural drawings, and all those together, it looks like there's about 68 pages of drawings, and then there's some specifications as well. But just to give you a brief sense of what that is we've got civil engineering that starts to lay out the site, figure out how things are going to be sloped. We've got structural drawings that are starting to indicate what direction the span of the trusses need to be, where some of the steel beam sizes are. You can see there that's an 1850 beam size. So it's really just communicating to the contractor, to the supplier, what all these things need to be. We also get into details. This is an example of some foundation details. But when we get into the architectural is more about laying everything out. So the structural engineer is going to tell you how big the beam needs to be. We're going to tell you where the beam needs to go. So this is our example, or this is our architectural drawings. Just kind of flipping through these real quick. There's a roof plan. And then we get into the building sections. We covered those a while ago, where we're starting to slice through the building and understand how those assemblies are actually going to be put together. You can see that there's quite a bit of complexity in this particular area where the garage door is, and the concrete, and how that beam actually creates this little beam here, makes this little inset for the house, or for the primary bedroom to set on top of the floor in a very distinct way. It also gets into wall sections. That again, wall sections are just a closer, zoomed in version of the building section that starts to communicate more of the specifics. And then we get into the details, which are even closer view, talking about rebar, talking about brick ties. So the point here is that all of these drawings combined are showing all the decisions and communicating all the decisions to not only the contractor, not only the subcontractor, but the window supplier, the truss manufacturer. All these folks need to know what the overall is going to be, what the overall design is, and then the drawings are created starting very broad and then working into detail, layering all the information on top. And then as you get deeper into the drawings, you have more and more specific answers to the questions of the design. So that was a lot. I know it's kind of the back of house stuff. It's how we're actually going to figure it out. As a homeowner, the thing that you're going to want to be primarily concerned with during the design process is that schematic design phase, because that's where you're going to see the most impact on you. I'm not sure that I have a whole lot of homeowners that care much about how big beams are or how flashing details work. But in general, just know that once you get through the schematic, you have to go in and we have to create drawings and figure out how we're actually going to build the house. And that is a big chunk of the work. So where schematic design was worth like 25% of the overall workload in terms of the design development and the construction drawings and creating the specifications are going to be the rest of it. Now, the next stage of the design process is actually the construction administration stage. And I will create a video about that and give you an overview of what that is. But just know that the construction administration phase is all about making sure that the drawings are being communicated to the suppliers, to the subcontractors correctly, and that we're actually staying on board during the construction process in order to help the contractor build the project. So if you have any questions, please leave a comment. I love helping folks figure out what their project is, figure out what their next steps need to be. So leave a comment, follow, and I look forward to seeing you in the next one.